Hello, welcome to Sommerfeld's extension of Bohr's atomic model. Sommerfeld's extension of Bohr's atomic model. Actually, Sommerfeld extended Bohr's model in 1915 to account for the fine structure of line spectrum of hydrogen atom by putting forward the idea of elliptical orbits. This is the idea of elliptical orbits. Okay, according to Sommerfeld's modifications, electrons revolve around the nucleus can set their motion in elliptical orbits under the influence of nuclear charge. These elliptical orbits have major axis and minor axis with different lengths. Major axis and minor axis with different lengths. As the size of the orbit increases, the two axes become equal in length and the orbit becomes circular. If you see like this is one, this is another one, this is another one. If you see this kind of picture, you will come to know that size of the orbit is increasing, then two axes becomes equal in length and the orbit becomes circular. In Bohr's model, orbits are mentioned. N is equals to 1, 2, 3, 4, etc., where n is called principal quantum number. Sommerfeld used two quantum numbers, that is radial quantum number nr and azimuthal quantum number n phi. What is it? Nr is radial quantum number, n phi is azimuthal quantum number. So, in this discussion, we will come to know that these quantum numbers are related to the geometry of ellipse as n by n phi is equals to nr plus n phi by n phi. So that is the meaning, is nothing but length of major axis, length of major axis divided by length of minor axis. Length of minor axis. These can be having some possibilities are there in this one. We have, if the case is different, that is if n phi is less than n, the length of the minor axis will be greater than that of major axis and the orbit remains elliptical. Suppose if you take this information like this, that is n phi is equals to 1 for this small one, n phi is 2 for the second one, n phi is 3 for the third one. So here what is happen? If n phi is greater than n, then it remains elliptical. If both this is the condition elliptical, and if n phi is equals to n, the length of the major axis will become equal to that of minor axis. Orbit becomes circular. Orbit becomes circular. This means n phi and n have the values. If we have n is equals to 3, then n phi will have the values 1, 2, 3. Two elliptical orbits, 2 elliptical orbits, and 1 circular orbit in this case. If n is equals to 2 we have, then n phi will be 1 and 2. So in this 1 elliptical orbit and 1 circular orbit, 1 elliptical and 1 circular, if n is equals to 1 we have, and n phi is equals to 1 circular orbit will be 1 circular orbit. Okay, so this is the idea of elliptical orbits. Now let us see. Applying principle of quantization of moment to the electron revolving in elliptical orbit. So this is elliptical orbit. If electron is revolving in elliptical orbit, Sommerfeld reduced the energy of the electron to hydrogen atom as energy of hydrogen atom was minus 2 pi square me power 4 by n phi plus nr square whole square into h square. This means energy of the electron depends upon two quantum numbers, that are n phi and nr. Hence the electron transition from one energy level, if you take n1, suppose if it is n1, to the another energy level n2, okay, it results into closely spaced lines in hydrogen spectrum, depends upon various possible values of n phi. However, Sommerfeld theory could not predict the correct number of lines observed in a fine structure.